Good day, folks. Welcome to Bright Mind Academy, where we bring brilliance to every lesson. Now, in today's video, we're going to be looking at a common June test written by those who were writing the KZN question paper in June 2022, right? So this is for grade 11s. All right, so let's just dive into it. So we have now question 1, which we all know that it is what? It is equations and inequalities, right? Yes. Now let me quickly do this. Grab my mouse. Okay. Now we have 1.1 now saying to us, solve for x, right? Yes. So we have x into 1 minus 2x, it is equal to 0, something like x 1 minus 2x, it is equal to 0. So how can you solve this? We know now, we say, okay, it's either x, this x, it is equal to 0, or the inside bracket thereof, which is 1 minus 2x, it is equal to 0. Therefore, remember, I can solve this one any further, right? So I can take this, okay, I can take this 1 to the other side so that it becomes negative 2x, it is equal to negative 1, x, it is equal to what? Divide by 2, it becomes half. So my values here, it is x, it is equal to 0, or x, it is equal to half. Okay, yes. Okay, yes. Okay. Now moving forward, we have 2x, 2x squared minus 5x plus 3 is equal to 0. Okay, there are many ways in which you can solve this, but okay, I have my own method. If you have your own method, it's fine. But what's important, the off, it's getting the same answer, okay? So what I do is now say 2, let me get I say 2 multiplied by 3, I do this, okay? 2 multiplied by 3, it is how much? 2 multiplied by positive 3, it is 6. Then the middle term, it is negative 5. So now what do? I want factors of 6. Remember, this is positive, right? So I want factors of 6 in such a way when I add them, can you see this is positive? They give me 5. So which one are those factors of 6? I can say 6 and 1. When I add them, they give me 7. Then I have 3 and 2. When I add them, they give me 5. So it means it should be 3 and 2. But I want them to give me, instead of 5, what? Negative 5. So if I say this, it becomes negative 3 plus 2, which is negative 1. When I add negative here, it becomes negative 3 plus negative 2, which is negative 5. Therefore, it means I'm done, but I'm not done. I have to divide by the coefficient of x squared, okay, which is 2. Divide by 2, divide by 2. Then I can simplify this any further. This can be what? Negative 1 divided by 1. So your denominator will always be something x, okay? Can I simplify this? No. So it means this is negative 3 divided by 2 by 2x, okay? Yes. So it means I'll have factors such as, what here? I'll have 2x minus 3 and what? And x minus 1, it is equal to 0. Then you know how to solve this. Again, you say 2x minus 3, it is equal to 0, or x minus 1, it is equal to 0. Therefore, here you have x, it is equal to 3 divided by 2, or x, it is equal to 1. However you solve this, what's important is you getting here, right? You getting to this point, okay? Yes. So let me move on. 1.1.3. I have now x into 3x minus 5, it is equal to 7. They tell me correct to 2 decimal, okay? Remember, when they tell you to 2 decimal, what you have to think of is that you have to apply what? A quadratic formula, right? So first thing first, let me apply 0 factor or standard form, okay? So I'll multiply this one out. So when I multiply that out, it will be something like 3x squared, again, minus 5x. Then I take this 7 to the other side, it becomes minus 7, it is equal to 0. Okay? Therefore, if that's the case, I do what? I say, okay, remember they told me I should correct this to 2 decimal. So it means now I can say x, it is equal to negative b plus or minus square root of b squared minus 4ac divided by 2a. Okay, yes. Now x, it is equal to negative b. It is what? Remember, this is a, this is b. B, it is negative 5. C, it is negative 7. Okay, so I can be in a position of substituting and saying now this is what? I can't locate my mouse. Let me quickly do that. Oh, okay. My mouse is not working. Okay, good. So yes, I have negative. What is b? B, it is negative 5. Plus or minus square root of what is b? B is negative 5. Squared minus 4. What is a? A, it is 3. What is your c? C, it is negative 7. Divided by, okay, I'm writing weirdly now. Okay, I doubt you'd see that. Let me try to rewrite that. It is negative b. What is b? I say b, it is negative 5 plus or minus square root of b squared minus 4ac. Okay, divided by 2a. That's what the formula says. What is a? A, it is 3. Okay, then remember, when you punch your calculator, you first punch when x it is equal to positive 2. Sorry, when x here it is positive, okay, not x. When here it is positive, then you come back again, you change that sign into what? Into negative, okay? So it will be something like negative into negative b plus square root of b squared minus 4a, it is 3, c, it is negative 7. When you substitute, make sure that you substitute with those brackets there of 2 into 3. For the positive one, I get 2 comma, remember to decimal. Sorry, I get 2 comma 57, or x it is equal to, when I put negative, no, 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 no. Okay, I get, when I put negative, I get something like, please confirm with on your calculator also if you get the same answers. I get negative 0.91 to 2 decimal. Okay, yes, these are your two answers for 4 marks. Okay, for 4 marks, you have to apply 0 filter. This is the first mark. Then substituting into the formula, then the two values, 1 mark each. Okay, let's move on. 1.1.4. It says now, okay, solve this is the inequality, right? You have to solve for this inequality. Now, first thing first, I refer you to take this into a standard form, right? When you take this to a standard form, remember you have to multiply out here, all right? It becomes 1 multiplied by x, it will become x. Okay, let me do this. 1 multiplied by x, it becomes x. 1 multiplied by 3, it becomes plus 3. Negative x multiplied by negative x, it is negative x squared. Negative x multiplied by positive 3, it is negative 3x. Then allow me to take this 5 to the other side. 5, it is less than or equal to 0. Then what happens here? I have negative x squared. I rearrange them. X minus 3x, it is negative 2x. Then 3 plus 5, it is plus 8. Okay? Yes. So less than or equal to 0. Now, I do not want to work with negative. When I divide by negative 1, what happens? When I divide by negative 1 thereof, it means now I have to also change the what? The sign. I also have to change the sign. So when I divide by negative, it becomes x squared plus 2x minus 8. This sign should change into this, okay? Because you're dividing by negative 1. Remember, when you divide by negative 1 or multiply by negative 1, the sign change, okay? Sign change. Don't forget that. Then now let's try to simplify this. It will become x plus 4, x minus 2 greater or equal to 0. Now, do not say x is greater or equal to 4 or negative 4. No. Here you want your critical values. Your critical values will be what? You equate this to 0, it will be negative 4. You equate this to 0, it will be 2. Okay? Then you come here. You draw. Okay? Remember, what is this? Remember, this is a quadratic pattern. Okay? So for a quadratic, I'll show you two steps. Two methods rather. The first one, it is you saying, okay, this is negative 4, this is 2. This is a quadratic formula, right? And it has a positive gradient. Remember, if a quadratic formula, the parabola, if a is greater than 0, it is happy. If a is less than 0, it is said like that, okay? So here we can see a, it is positive, it is positive 1, so it means it is happy. So it will be something like that, okay? Now we want where it is greater than 0, greater or equal to 0. Where is it? Greater is this part. This part it is greater. This part it is greater. Whereas this one it is less. Can you see that? So it means now which values do we want? We want where x is less or equal to negative 4, or where x is greater or equal to 2. Can you see? It is from this point to there, or from this point to there. Another method that you use is this one. You say, okay, this is negative 4, this is 2. Let's put a value between that is less than negative 4 on this side, on this equation, or whatever equation, right? So when I put negative 5 here, it becomes negative 5 plus 1 plus 4, it becomes negative 5 minus this one, it is negative. So in here it is positive, okay? Then when I put something between negative 4 and 2, which is 0, maybe 0 times this, 0 plus 4. When I substitute 0 here, it is 0 plus 4, which is positive 4. 0 minus 2, it is negative 2. Then positive by negative, it is negative. Remember, if it is positive, it becomes negative, this becomes positive. So we want where it is greater than 0. Greater than 0 means it is positive. So it will be from this point, and it is shaded because it is included there, okay? To where? To there. Then it is from here to there. So similarly, your x will be less or equal to 4, or your x will be greater or equal to 2. Just like that. Okay? Just like that. I know it is a lot of mathematics, but yes, you have to apply now the fundamentals thereof. Okay? If you did not understand that one, please try to go back and try to digest that and try to do your own so that you can see if you understand. Then here we have something like x squared. Let me write it here. X squared plus 7 all divided by x squared minus, okay, let me write that, x minus 3 plus 2 into x plus, 2 divided by x plus 1, it is equal to negative 1 divided by x minus 3, okay? This is what we have, okay? This is what it is written here. So what I'll do, I'll take this part to the other side. So what I'll do, I'll take this negative to the other side so that it becomes positive. Positive what? I take this to the other side so that it becomes positive. 1 divided by x minus 3, it will be equal to 0, okay? Now what I need to find here, it is the lowest common factor. But remember, I can simplify this. What is x squared minus 2x minus 3? I can simplify this into x minus 3, x plus 1. So I can rewrite this into what? X minus 3, x plus 1. Can you see that this one has both of them? This one has one of the factors here. This one has one of the factors. So it means what? It means now our LCD will be x minus 3, x plus 1, because this one has both of them. This one has 1, this one has 1. So it means if we want this one, this one already has both of our LCD, right? So it means you have to multiply this by the one that is short of it, all right? Which is this one. This one does not have x minus 3. This one does not have x minus x plus 1. Okay. So according to equations, if you have an LCD that is common for an equation, you can drop all those. You can ignore the what? The denominator. Okay. But it's fine. We'll see. We have what? X squared plus 7. This will be all under one denominator. I want you to take note of that. All under one denominator, x minus 3, x plus 1. Then you say plus. Can you see now? This one will be 2, but I will multiply by what? By x minus 3, because it does not have x minus 3. It has only x plus 1. Okay? Then plus 1. Then the one I'm going to multiply it with what? It is short with x plus 1, like that. Okay? Then what will be, okay, it will be equal to 0. Let me do that. This will equal to 0, okay? Then I'll try to simplify. And now I want you to take note, when you multiply this part to the other side, when you do cross multiply, sorry, this will become what? This will become 0. So now the rules of equations now says, if you have all common denominator, you can ignore the denominator only in equations. But if you work with expressions, you cannot. So I can say this is x squared plus 7 plus, can you see 2 multiplied by x? It is 2x. 2 multiplied by negative 3, it is negative x, plus 1 multiplied by x, it is x. 1 multiplied by 1, it is plus 1, it is equal to 0. Why? Because when I multiply all of this part to the other side, it becomes 0. Then I can now do my mathematics. X squared, it is alone. 2x plus x, it is positive 3x. 7 minus 6, it is 1, plus 1, it is 1. 2, it is equal to 0. So then I can solve this. What is this? This is the same as x plus 2, x plus 1, it is equal to 0. Okay? Then now, I can say now, x, it is equal to negative 2, or x, it is equal to negative 1. So this is basically what was required from you. Okay. First thing first, you find the common LCD. Then you multiply the ones that do not have any of the LCD with what is short. For instance, this one, can you see it has only x plus 1? This one only has x plus 1. So it means you have to multiply by x minus 3. Okay. This one only has what? X minus 3. So it means you can multiply by x plus 1. Then you do your mathematics. There. This is me showing. Then remember I said you can ignore the denominator and work with only the numerator and then become a mathematician and solve. Okay? Yes. So another thing again now that we should look at it is 1.2. Okay? 1.2. Let's look at 1.2. 1.2, we are given this. I know it is not visible due to these pictures thereof. It's the website that I used. So we have x minus 3. It is equal to 2 square root of x. Okay? Now they say solve for x. What we can do here, we can try to remove the square root, okay? Remember, when you try to remove the square root, you have to square both sides. So it means you can say x minus 3 squared. It is equal to 2 root x squared. Okay? You might remember what you do to this one. You square the first term, it becomes x squared. You can say x minus 3 and x minus 3 and you work out, it's fine. But you square the first term, then you say the first term multiplied by the second term, which is negative 3, multiplied by the power, which is negative 6x. Then you square the last term, which is 9. Then here, when you have 2 square root of x, when you square that, you'll square 2 first, which is x. Then you'll square square root of x, which is x. I repeat, you square 2, it will give you 4. I said x. Then you square 2, it will give you 4. Then square root of x, when you square that, this square and this square root will cancel off. So here you have something like 4 for x. Then apply zero factor, x squared minus 6x minus Can you see I take this 4x to the other side? Minus 4x plus 9, it is equal to 0. But remember here, you are working with this part, the set form. When you have the set, you have to confirm both your answers that you get. You should confirm them, okay? Then you have what? X squared minus 10x plus 9, it is equal to 0. Then, when you do your math there, x minus, okay, x minus 9 and x minus 1, it is equal to 0. X it is equal to 9 or x it is equal to 1. On this one, we should test if both the answers are correct. Now, let's come back to this equation. Let me write it here. Let's test if both our answers are correct. Now, let's put the first one. Let's put x it is equal to 9 and see. We are test. This one you have to do it, even if you do not show it on your book, but you have to do it aside. When we put 9 here, it will be 9 minus 3. It should be equal to this side. Okay, 9 minus 3, it is 6. It is equal to 2 multiplied by square root of 9. Square root of 9, remember, it is 3. Then 2 multiplied by 3, it is 6. So this one, it is correct. If it gives us the correct one, it means x it is equal to 9 is correct. Then we have to test using what? Using 1. So it's going to be what? 1 minus 3, it is equal to 2. The square root of 1. What is 1 minus 3? It is negative 2. It is equal to 2 multiplied by, remember, square root of 1 is the same as 1. So this is 2 multiplied by 1. This is 2. Can you see now these are not equal? So it means now x is not equal to 1 because it does not give us the correct answer. Okay. Now you are done. You are done. Okay. But now 1.2.2 says, hence, if this one is a great, this part, cube root of 3t minus 2 square root of cube root of 3t, it is equal to 3. Determine the value of t. When they say hence, there are high chances that you're going to use whatever that you got here to help you there, okay? What do I mean? Remember, you got that x, it is equal to, let me do this. You got that x, it is equal to 9 for this one, okay? You got that, how? Okay, let me do this. You got that x, it is equal to 9 and x is not equal to 1, so it's not important. So here, I want you to see, if I take this one, x minus 3, it is equal to 2 square root of x. When I rewrite it like this, can you see here, instead of saying x minus 3, they did x, they take this 2 square root of x, it is equal to 3. Okay, this is the same. This is the same. But now, they replaced what? X with how much? With with okay, I want to say something. Or they replaced x with cube root of 3t. X replaced x by cube root of 3t. Can you see where it was x? Can you see here? It is x, but now we have cube root of 3t. Here we have 2. Here is that 2. Then square root of x, but x now, it is now what? Cube root of x, cube root of 3t. Can you see that? They replaced x with that one. So it means now our new x, it is what? It is this. So they say determine the value of t. This equation, it is the same as this equation, just that they have rewritten it, right? But now remember, you have already solved for this equation. So instead of getting x, it is equal to 9. Instead of getting x, it is equal to 9. When now you will get what? When now you will get this. This is our new x. So instead of saying x is equal to 9, you'll say cube root of 3t. It is the one that is equal to 9, because now why? They replaced x with what? With cube root of 3t. So then you have to solve. How can I do that? Remember, you are trying to solve for t. You can say cube root. Remember, how do you remove cube root? You have to cube that, okay? you have to multiply, raise that to the power of 3. But remember, on the equation, what you do on your left, you also have to do on your right, like that. Then you have what? Then you have what? Let me try to remove this. Then remember, when you cube something, this will remove this, okay? Then we'll be left with what? With 3t. It is equal to 9 times 9 to the power of 3, rather. 9 to the power of 3 is 9 times 9, which is 81. 81 times 9. Yeah, I don't know. 9 to the power of 3. 729. Okay, 729. Therefore, we have to divide t. Okay, therefore, 729 divided by 3, you get 243 as your answer. Okay, this one was a little bit tricky. It wanted you to just understand. Okay. Yes. All right. Cool. Let's move on to 1.3. They say now solve simultaneously. What? Let me see if I'll have enough space to solve that. I'll try. Okay. Solve simultaneously for x and y, right? So what we might do here, I might, okay, say this one, it is my equation 1. Okay. This is my equation 1. This is my equation 2, right? Then can I try to solve this in terms of x? Yes, I want to make one equation in terms of something, okay? I can make this in terms of x. I can say, take this one to the other side and say x, it is equal to 3y minus 1. Can you see I took this 1, I took it to the other side. So this becomes my equation 3. Then what can I do here? What can I do here? I can simplify this, okay? How can I simplify this and multiply out, multiply out? When I do that, I get x multiplied by this one. It becomes, x multiplied by 5y, it becomes 5xy. X multiplied by negative 3x, it becomes negative 3x squared. Negative y multiplied by 5y, it becomes negative 5y squared. Negative y multiplied by negative 3x, it becomes positive 3xy. It is equal to 0. Then this I can say it is my equation 4. Okay. Now, if I have these equations thereof, I can substitute. Can you see this one is in terms of x only? I know what x it is equal to, so I can replace that there. So I can say substitute equation, okay? Substitute, sorry, equation, okay, let me say equation 3 into equation 1, 4. We are trying to substitute x as 3y minus y into this equation. So what I'm going to do, I'm going to say, where's my equation 4? It is 5, but when I see x, I'll substitute what? Let me do this so that you see I substituted. Okay, still multiply by y. Minus 3, I have to substitute x as how much? As 3y minus 1. But remember, I have to do what? I have to square that. So that square is still there. Minus 5y squared plus 3, I still see x. When I see x, I substitute by 3y minus 1. And I still have to multiply by that y. It is equal to 0. Then it's just a matter of simplifying here, right? How can you do that? You'll just say, yeah, you'll do your mathematics. 3y multiplied by y, or you start with 5, either way, okay? So remember, let's start with this one. I'll say 3y multiplied by y, it is 3y squared multiplied by 5. You can say 5 multiplied by 3y multiplied by y. And come again and say 5 multiplied by negative 1 multiplied by 3 by y. So it will give you something like 15y squared minus 4y minus, then when 3, you have to solve this one first, okay? The bracket and the bracket, remember it is twice. So this is going to be 9y squared. You can do that however you do that, okay? 6y plus 1 minus 5y squared plus, then still this time that it's going to be negative 9y squared minus is equal to 0, okay? For how many marks? For 5 marks. Okay. Then 5y squared. Okay, let me try to simplify. When I simplify this, can you see now it becomes? Okay, let me rewrite that. 5y squared minus 5y minus 27y squared plus negative by negative, okay? 3 times 6, it is 18y. Negative by negative, it is negative 3. Then, yeah. Make sure you do not do any mistakes. If you see any mistakes, please leave them in the comment section so that I'll see them. Then now we want all y squared. Y squared, I take with the negative y squared. I take with the negative there. I take this with the negative. I add them together. Okay, I say 15y squared minus 27y squared. I get negative 12y squared minus 5. It is negative 17 y squared minus 9. It becomes negative 26. Let me confirm that with my calculator. You can say 15 minus 27, 27 minus 5 minus 9 is negative 26y squared. Then I come back to the other ones, the y's. Okay, let me do this. The y, negative y plus 18. You take with the sign, negative 3y. Okay, negative 5y plus 8y, it is 18y, rather it is positive 13y minus this, it is plus 10y. Then you go where we are left with the what? With a constant. Where is it? Negative 3. Okay, let me try to confirm if I did everything correct. Yes, yes, yes. Okay. Now it's just a matter of, okay, I like to divide by negative 1 so that I do not work out more with the negatives. So here I have 26y squared minus 10y. Let me write that plus is equal to 0. Then now I can use quadratic formula here. Okay, I can use quadratic formula here. When I use quadratic formula, I get something like, let me show you. Mm, Okay, I found a faster method, right? So instead of manipulating this one, I can just say, okay, we will start afresh. We'll just say this is 3y, it is equal to, okay, like I can say x plus 1 like that, okay? Then this one, and say now instead of applying anything, let's say x minus y, let it become to 0, then 5y minus 3x equal to 0. So if you do that, assume that you are solving for x here. So we know we'll say the first one will be, let me just say this is one. The first one will be what? X, it is equal to y, okay? Or what? Let me show you why. I'm saying x minus y it is equal to 0, or 5y minus 3x it is equal to 0. So you can say x it is equal to y, or here when I want to solve for maybe y or x, either way it's fine. I take, let me solve for y. It's going to be y is equal to negative or positive 3x when it goes to the other side, divided by 5, okay? So I can say now x, it is equal to y as equation 2, y is equal to as equation 3, okay? What I can do is that I can take this one, equation 2, into equation 1. When I do that, I get that x is equal to y. So it means where I see x, I substitute what? Y. So it will be something like 3y is equal to y plus 1. Okay? Then I'll get what? I'll get, this is 2y, it is equal to 1. Then y will be equal to positive half. Okay? Then how do I get x? How do I get x? Remember, x it is equal to y. Okay? So x is equal to y. So I can say, therefore, for this one, x it is equal to, remember this equation says to me x is equal to 1, so I can say, oh, it means x it is equal to 1 again also. 1 over 2, sorry. Then say what? Remember you got two equations, so you can say sub equation 3 into equation 1. Can you see that? Yes, so when I sub, I see y is equal to this, so I substitute 3 into, when I see y, I get what? I input 3x divided by 5, which is equal to x plus 1. I don't like how this question was structured, but yeah. So I have 9x divided by 5, it is equal to x plus 1. Then remember you can multiply by 5, you get 9x, it is equal to 5x plus 5. Then 4x, it is equal to 5. Then x, it is equal to 5 divided by 4. Then when you want to get y, you come to this part, you say y is equal to, you substitute x as this one. We're going to say 3 divided by 5. Then you substitute x as 5 divided by 4. 5 divided by 4. Then y, it is equal to, this and this will cancel, 5 and 5 will cancel. Then you'll be left with 3 divided by 4. So here are your 2x and your y's. Okay? Yes. Yeah, hopefully the examiner will never give you something that's this, yeah, like that. Okay? So yes. Hope you understood that. Okay. What do I want there? Let me erase that so that we do the last part of 1 point something. Where is that? Where is that? I get. I see. Okay, 1.4. 1.4, I'm told that the root of the equation, this one, are that. But remember, if you have something like this, x, it is equal to 3 plus or minus. Remember, you have what? The formula says x it is equal to negative b plus or minus square root of b squared minus 4ac divided by A. But now, remember the roots. What do we know about the roots? We know the root is equal to what? The discriminant, which is b squared minus 4a or c. So it means whatever that's here, it is your what? It is your roots, your discriminant, your root. So they tell us the roots for this equation are that. So we know we are going to get the discriminant from where? From the bracket. But can you see now? In this case, it is written in a way that is not a standard one, because here we do not have something outside the bracket. So it means we have to take this 3. Okay, from this equation, let me rewrite that neatly. From this equation, which is x, it is equal to 3 plus or minus. You have to try to make this one inside the square root, all of it inside the square root. So how can you do that? How can you do that? It's easy. Remember, we had, so it means it was square root of 5 multiplied by something. Okay, but that something here was a square, such that when they take a square of this number here, it gives us 3. So if we want to take this 3 inside the square root, you have to square it. Okay, so 3 squared, it is what? It is 9. So 5 multiplied by 9, it is what? It is 45. So here it is 3 plus or minus, this was 45. Okay, yes. Okay, or you can punch your calculator and say 3 square root of 5 and see how much it gives you. Okay, but yeah, it does not give you that answer, but yeah, it is 45. Okay, divide by 2. So now can you see this is our discriminant now? Okay, can you see for this one our discriminant, it is equal to what? 45. Okay, yes. But now what we can also do is that, let me try to shift this one. Okay, that's fine. Let's try to find the discriminant for this one. Okay, so I know for this one the discriminant, it is what? B squared minus 4ac. Remember trying to solve for k. What is b? B, it is negative 3 squared. Oh, sorry. Negative 3 squared minus 4. What is a? A, it is 1. What is c? C, it is negative k. Then here we have 9 minus negative 4 multiplied by 1 multiplied by negative k is plus 4k. Okay, so we have two discriminants here that should be equal to this one another. So this one is the discriminant, so this one is the discriminant. What you can do is say, okay, so it means 9 plus 4k, which is equal to 45, because they are the discriminant of the same equation. Because this equation, this one, they got it from this one. Okay, yes. So how do I solve for that? I can say 4k, it is equal to 45 minus 9, it is 36, if I am correct. Then when I divide by k by 4, rather by 4, I get something like 9. So my k, it is 9. I hope you understand that. Okay, yes. So we move on to question 2. Question 2 now, we have this part, right? So it is given as let me try to rewrite that quickly. We have 2 to the power of 6x multiplied by 27x multiplied by 3 to the power of x. If you can see now, we have something with regards to 2. This is 2, this is 2, this is 3. Remember 9, you can change it to 3. You can change this to 3. 6, can you change that? No. Okay, so the easier part to change 9, take your calculator and say 9 equal sign shift, then fact. There is something that is written fact there on these buttons that are a lot, or it is something like this. Oh, sorry. Let me see. Oh, something like, then at the top it is written fact. So say 9 equal sign shift that one, then we'll get the answer, okay? So let's evaluate this. It's going to be equal to 2 to the power of 4x plus 1 multiplied by, when you do that, this gives you 3 to the power of 2x multiplied by, when you do this, when you say 6 equal sign shift fact, it gives you 3 times 2, right? So we just say this is 3 multiplied by 2, what? 2x minus 1, all divided by 2 to the power of 6x. Remember, I'm trying to make them in terms of 2 and 3. 27, when you do that, it is 3 to the power of 3x multiplied by 3 to the power of x. So let's simplify it a little bit. So this one we leave it as it is, 4x plus 1 multiplied by 3 to the power of 2x multiplied by x, right? Then this 3 will take the denominator, the exponent as it is. It will be 3 to the power of 2x minus 1 multiplied by 2 to the power of, it takes the exponent again, all divided by what? 2 to the power of 6x multiplied by 3 to the power of 3x multiplied by 3 to the power of x. Now I have everything. Let me come here. I have everything 2, everything 3. So I take 2, arrange 2, then arrange the what? The 3's. But remember, we have if a to the power of m multiplied by a to the power of n. If you multiply the same base, we do what? We add the exponents. Remember that? And if we divide the same base, we do what? We minus, we subtract the exponent. So yes, let's look at the 2's. 2 to the power of, we look at this one. It's 4x plus 1. Then we add this one. Can you see this one and this one? They multiply each other, right? Then also this one, but this one, it is at the bottom, so it will subtract. So it will be 4x plus 1 when we have to add the exponent. Plus, can you see when I add the exponent, I put the bracket because it is binomial. Okay? Then this one, it is at the denominator. What do I do? Remember, I said if they add the numerator and they multiply like that, we add the exponents. If they divide, we subtract the exponent, minus 6x. Plus, we look at the 3's. The 3's, this one, these ones. Okay? So the first ones, they are at the top. So it's going to be 3 to the power of 2x. We add them. When we add that, it's going to be 2x minus 1. But this one, it is at the top. Can you see this one? It is at the top. Sorry, at the bottom. So if it is at the bottom, I minus 3x. Minus this one, it is at the bottom also, like that. Then it's just a matter of simplifying here. Okay, can you see now? I have 4x plus 2x minus 6x. So 4x plus 2x, it is 6x minus 6x, it is 0. Then I have what? 1 plus minus 0. 1 minus 0, it is how much? It is 0, right? So it means here I have 2 to the power of everything, it is 0 here. Plus 2 to the power of x plus 2 to the power of x, it is, sorry, 2x plus 2x, it is 4x minus 3x, it is 1x minus x, it is 0. Then here I'm left with what? With negative 1. So I'll say negative 1. Remember, any number to the power of 0, it is 1 plus, when you take this on your calculator, it is 1 divided by 3, right? Then when you evaluate that, you get something like 4 divided by 3, if I'm not mistaken. Yes, 4 divided by 3. So this is your answer. 4 divided by 3. For 4 marks. Okay, yes. For 4 marks. So let's move on to the other one. The other one says what to us now? Okay, this one looks a little bit interesting. Let me erase that quickly. Okay. What do I have? I have now 3 to the power of 2020. Okay, let me write that. 3 to the power of 2021 minus 3 to the power of 2017, all divided by 60 multiplied by cube root of 3 to the power of 6048. Okay? Remember, you do not use calculator in these equations, okay? So let's leave this one as it is for now and try to see what is happening at the top. Here, you can take out the highest common factor as 2017. Remember, if you have 3 to the power of 4 minus 3 to the power of 3, you take your common factor, it is the one with the lowest exponent, which is 3 to the power of 3. Can you see? Then you are left with 3 to the power of 1, okay, then minus 1. So similarly here, we can do that. I can say the factor is 3 to the power of 2017, okay, 2017, then I have 3 to the power, say 2021 minus 2017, it is 4. Minus this is 1, it is the same thing, just say 1. All divided by what? 60 multiplied by. Now, what is the cube root of this? Do not say cube root of, do not punch that on your calculator, all of it says 3, then say 6048 divided by 3. Remember your rules say now, if you have cube root, let's say 20 to the power of 6. So you're going to say it is 20 to the power of 6, 1 divided by 3. So it is the same as saying 20 divided by 6 divided by 3, which is 2, okay? Similarly here, you'll divide by this 3. So 6048 divided by 3, let me see, 6048 divided by 3, it gives me 2017. Sorry, 2016. Okay? So now, how can I evaluate that? Can you see now this one and this one? They can do what? They can almost cancel because, but in this case, we have a to the power of 2 divided by a to the power of 1. What do? We say a to the power of 2 minus 1, okay? So we can apply that here. So when I say 3 to the power of 2017 minus 3 to the power of 2016, it gives me what? Give me something like 3 to the power of 1. Multiply by this one, 3 to the power of 4. 3 to the power of 4, it is how much? 3 times 3, it is 9. 9 times 9, it is 81. Minus 1 divided by 60. So this is just 3. Can you see that I can simplify this? 3, it gets here once, and 3 into 60, it is 20 times. So I can have something like h1 minus 1, it is 80 divided by 20, which is 80 divided by 20, it is the same as 8 divided by 2, which is 4. Okay, yes. This is how we do that. Okay, yes. Now let's move on to 2.2. So we have m, we have m to the power of 8x minus 4, it is equal to 1. Okay. So we try to solve for what? For x here. But how can I do that? Remember, I can do nothing. There's nothing I can do unless this one was m, okay? But can I do, is there something I can do to this one and make it to the base of m. But remember, yes, I can do that. Why? Because anything to the power of 0, it is 1. So m to the power of 0, it is same as 1. So I can rewrite this one as what? I can rewrite this m as m to the power of 8 x minus 4. It is equal to m to the power of 0. M to the power of 0 is the same as 1, okay? Then after doing that, they say if I have the same base, I do what? I equate the exponent. If I have the same base, I equate the exponent. How do I do that? I say 8x minus 4, it is equal to 0, then I can solve. Okay? X is 4 divided by 8, it is half. So this is how you can solve that one. I hope you are following. Then for this one, 2.2.2, we have 4 multiplied by 3 to the power of x minus 3 to the power of x minus 2 plus 3 to the power of x, it is equal to 44 divided by 3. How can I simplify this? Now I want you to see something. Remember this one, I can expand it. Why? If I have m to a to the power of m plus n, the rule say I can do this multiply by e to the power of n. Okay, let's apply that. I can say this is 4 multiplied by 3 to the power of x minus 3 to the power of x multiplied by 3 to the power of negative 2 plus 3 to the power of x still equal to 44 divided by 3. Then now, can you see this is a common factor? Okay, yes. I take out that highest common factor as 3 to the power of x. Here I'm left with 4 minus, here I'm left with 3 to the power of negative 2 plus, here I'm left with what? With 1 divided by 44 divided by 3. This one, they did not say do not use, or without using a calculator. Okay, it's fine. But this one, you can just punch this on your calculator, okay? The examiner wouldn't see, it's fine. You can just punch this on your calculator. You can say this is 3 to the power of x multiplied by, when you punch this on your calculator, you get how much? 4 minus 3 to the power of negative 2 plus 1. Oh, okay. Plus 1. So I get something like 44 divided by 9. It is equal to 44 divided by 3. I'm trying to divide, I'm trying to be left with a to the power of x. Remember, if I have a divided by b, divide by c divided by d, I can remove this, okay, divide. I can remove this division sign by saying a divided by b multiply by the reciprocal. Okay, yes, but in this case, I will do what? I will divide both sides by 44, divide by 9, divide by 44, divide by 9. When I do that, this and this cancels off, right? Then I'll be left with 3 to the power of x. It is equal to now 44 divided by 9. You can take this to a calculator. Remember, I said when you want to change this to a multiplication, you'll say multiply by, then you have to change this into 9 divided by 44. Even here, you can say, if you want to remove this, if you want to remove a divided by b, you have to multiply by b divided by a. So that this and this cancel, this and this cancel. Okay. So here you can multiply by the reciprocal, which is 9 divided by 44. Similarly, you can, what you do on your left, you have to do on your right. Then can you see that 44 and 44 cancel, then divided by 3, it is how much? It is 3. Then this is power 1 x, it is equal to what? 1. Just like that. Okay. Just like that. Now I look at the 2.2.3, I have x to the power of x. It is equal to 2 to the power of 4084, or sorry, 2048. Now I'm trying to solve for x. I want to do this part. I want to make this part in a way such that it will equal what? It will be something like 2 to the power of, I want this one to have maybe something like 2 to the power of 2, okay? Or 8 to the power of 8, so that it becomes the same as this one, as this format, okay? So how can I do that? I can say this is x to the power of x is equal to, I can say 2 to the power of, I write this as 2 multiplied by, divide this by 2, it gives you 10, 24, okay? This is the same. So, okay, I now see, it means I can have x to the power of x, it is equal to 2 to the power of 2, I can say this is 4 to the power of 10, 24, okay? Then, but still, it does not give me the same base and exponent. I can say, okay, let me repeat the same process. Divide this one by 2 again. Or when I divide this by 2, it's going to be 2 multiplied by, when I divide this by 2, it's going to be 512. Okay? Then x to the power of x, it is equal to 4 to the power of 2. Sorry, 4 to the power of 2, it is 16. 512. Hi. Okay, I might get there maybe. Let's see, x to the power of x, it is equal to 16. Okay, I still have 16 like that. Let me write that, okay? Then let me divide this by 2. I'm going to say 2 divided by 2 multiplied by 512 divided by 2. Let me do that. 512, 512 divided by 2. I get 256. Okay. When I say 16 to the power of 2, I get 256. When I say 16 to the power of 2, I get what? 256 to the power of 256. So now, can you see now? This is the same as this. So if this is the same as that, so it means this x it is equal to that and x it is equal to that. Can you see now they are the same? Yes. So it means I can say, okay, therefore it means therefore x it is equal to what? 256. Because this x can equal to that, and this x can equal to that. Okay. Yes. Okay, when I look at question 3, I have g of x, it is equal to 1 divided by 2 to the power of x minus 4. Okay, remember now, if okay, we have y, it is equal to a to the power of x minus 2. If a is between 0 and 1, it means our function, it is a decreasing function. Okay, you can check my videos on exponential function. If a is greater than 1, it is an increasing function. So in this case, a, it is a half, it is decreasing. And we have our asymptote at negative 4. Q, it is our asymptote. Our asymptote, it is at negative 4. So now, write down the equation of the asymptote of g. Now, asymptote of g is that y, it is equal to negative 4. Or you can say q, it is equal to negative 4. This is our asymptote. Okay? Then calculate the y-intercept. For y-intercept, you do what? You let x equal to 0, right? So it's going to be y, it is equal to 1 divided by 2 to the power of, okay, I want what y-intercept, so I'll have to let x equal to 0, 0 minus 4, which is 1 minus 4, which it is equal to how much? Negative 3. So now y-intercept, it will be when x was 0, y was negative 3. Another part, calculate the x-intercept. Remember, for x-intercept, you let y equal to 0. Remember, g of x is the same as y, okay? So you can say 0, it is equal to 1 divided by, like that, minus 4. Take 4 to the other side. It is equal to, remember, if you have 1 divided by b, it is the same as b to the power of negative 1. Or if you have 1 divided by b squared, it is the same as 1, same as b to the power of negative 2. Right? So I can say this is, you can see this is what, okay, we haven't used the log yet. So I'll say this is 2 to the power of negative 2 to the power of x, like that. Okay, yes. Then, but what is 4? Remember, I say 4 is 2 to the power of 2. Then this is 2 to the power of negative 2x. If we have the same base, we do what? We equate the exponents. 2 it is equal to negative 2x, therefore x it is equal to negative 1. So if x is equal to negative 1, y was 0. Y was 0. Okay. They say now to us, draw a neat sketch of g of x. Clearly show the intercept if the x is as well as asymptote. Now, before I draw, I just do this. I know I say the shape will be a decreasing function, right? So I just do this. Okay, let me try to redraw that. This is my x, this is my y. First thing first that I plot it is my asymptote at negative 4. When I just done this, the examiner does not care as long as we have said, okay, this is negative 4. Okay. Then your graph, remember, see the graph, it should be a decreasing function. Why? Because your value of a, it is between 0 and 1. If this value was 2 to the power of x minus 4, it was going to be an increasing function. But now it is 1 divided by 2 to the power of x. It's going to be what? A decreasing function. Take note. But now we have points of important point 0 and negative 3. 0 and negative 3. So here, 0 and negative 3 here, and negative 1 and 0 maybe here, negative 1 and 0. So I have to join those points. Okay. Something like that. So here, my x, it is negative 1. My y, it is negative 3. You just need to label those. And this is the graph of t. Then you are done. Then you are done. I won't remove the graph, because yeah, maybe you might need that. They say now calculate the average gradient of G between x is equal to 0 and y it is equal to 0. Okay, so now they want us to calculate the gradient when x is equal to 0, which is this point. When x is equal to 0, do you all agree with me that when we substituted x is equal to 0, we got how much? Negative 3. So at x is equal to 0, we have a point 0 and negative 3. At y is equal to 0, we got a point which is what? Negative 1 and 0. So basically, they want us to find the gradient between these points. Okay? Okay. So how can you do that? Remember the gradient formula says, what is the gradient formula? I write it there. Here. I'll say the gradient, it is equal to, I'll say this is x1, y1, x2, y2. So x2 minus x, okay, y2 minus y1 divided by x2 minus x1. What is y2? Y2 is negative 3 divided by y1, 0. X2, 0 minus 1. Then you get something like negative 3 divided by 1, which is negative 3. So that is your gradient, basically. Okay. The examiner was trying to be smart then. Then write down the equation of k if it is given that k of x is equal to g of x plus 4. So if k of x it is equal to g of x plus 4, what is g of x? G of x, remember, it is what? 1 divided by 2 x minus 4. Then just add 4. Remember, this is just g of x. Okay, this is just g of x. Then how much do you get when you simplify? You get what? 1 divided by 2 x. Just like that. Okay, now let's look at question 4. So we have the function f of x. It is equal to a divided by x plus p plus 1 has an axis of symmetry with an equation is 1, okay? So let's try to rewrite this equation of symmetry in a good way. So let it become y is equal to something, okay? So when I take this y to the other side, now be y is equal to, when I take this x to the other side, it becomes negative x plus 3. So remember, this is our horizontal asymptote. This is our vertical asymptote. Now, okay, let's look at it. Write down the range of f. So remember the range of f. It is y is an element of real numbers, but y should not equal to the asymptote. This one is asymptote. Okay, should not equal to 1. If they wanted the domain, you would have said x is an element of real numbers, but x should not be equal to negative p, whatever the value of p is, negative of that. All right. All right. So here's the answer. Or you can say y is an element from negative infinity to infinity, but y should not be equal to 1. Okay. Determine the equation of the vertical asymptote of f. So they want the vertical asymptote. So this one, remember I said it is the horizontal asymptote. This is the vertical asymptote. How can we get that? Then we can, okay, remember when I take this part, it gives me the axis of symmetry, right? So yes, if I say y, it is equal to x plus p plus 1, this is the axis of symmetry, x plus p plus 1. So it means now, okay. Oh, so can you see that this one? Oh, sorry. This one, it is the axis of symmetry with a negative gradient. So let me try to find that one instead. Let me try to find the one with the negative gradient. So it's going to be negative into x plus p plus q. If you do not understand where does this come from, please watch my previous videos where I recorded them, the functions, okay? Yes, hyperbole function as well as, yes. All right. So it's going to be negative x minus p plus q. But can you see I already have negative x? So it means now this part, negative p plus q. Oh, okay, I already have my q. Remember my q, it is what? It is 1. Okay, so this part, all of this part should equal to what? To 3, because negative x is already there. So what do? I say, okay, negative p plus 1, it should equal to 3. Remember, I'm trying to make sure that this equation is the same as that one. And now, how do I find p? Negative p is equal to 3 minus 1, it is 2. Then p is equal to negative 2. So it means here I have x minus 2. Okay, but now remember, how do I find my what? My vertical asymptote. I'm gonna say x minus 2, it is equal to, it is equal to 0, therefore x, it is equal to 2. So this is my vertical asymptote. Y, it is equal to 1, it is my horizontal asymptote. Good. So now it means now we have our equation now being what? Y, it is equal to a into x minus 2 plus 1. So now we are told if f of 0 is equal to, we calculate the value of a. F of 0 is equal to 2 means if the value of y when x it is equal to 0, it is 2. So they tell us the value of y it is 2. Okay, the value of y is 2 when x it is equal to 0. And you see, remember you used to this part. It is equal to 2. But what? When x it is equal to how much? To 0. So it means you're going to come here and substitute y is 2, but now x should be how much? Should be 0. So then 2 minus 1, it is 1 is equal to a divided by negative 2. Therefore, a it is equal to how much? 1 multiplied by negative 2, negative 2. So that's the value of a. Okay, yes. So it means now we have an equation that is y, it is equal to negative 2 x minus 2 plus 1. All right, yes. Now they say calculate the x-intercept of f. The x-intercept of f, remember for x-intercept, you let y equal to 0. So I can come here and say y is equal to 0, negative 2 x minus 2 plus 1. Take this one to the other side, negative 1 is equal to negative 2 x minus 2. Then cross multiply, and this will be negative 1 into x minus 2, it is equal to negative 2. Then divide by negative 1, x minus 2, it is equal to what? Negative 1. Negative 2 divided by negative 1, it is 2. Therefore, x is equal to 2 plus 2, it is 4. So for x-intercept, when x it is 4, y was 0. Then they say what again? Sketch a neat graph thereof. Okay. Sketch a neat graph. Show all the x-intercept, the intercept with the axis and asymptote. Now let's try to find the y-intercept. Okay. For y-intercept, you let x equal to 0, so it's gonna be. Oh, okay. I think I removed in. Okay. Information that is important. All right. So let me try to find y-intercept. They do not want me to find it, but I just want to be sure if I have it, okay? So for y-intercept, I let x equal to 0. It's going to be negative 2 into 0 minus 2 plus 1. Negative 2 divided by negative 2, it is 1. So it is 1 plus 1, it is 2. So if this is my x-intercept, my y-intercept, it is equal to what? If x is 2, y is 8. Or if x is 0, y is 2. Okay. So now how do I draw that graph? I'll say my asymptote, it is at 1. My other asymptote, remember we got 2 here. Okay, this is the vertical asymptote. So it will be something more or less like this. Okay, this is good. Okay. I have an asymptote at, okay, I'll just do this. I have an asymptote at 2, right? Let me say here it is 2. And asymptote at positive 1. Let me say here it is positive 1. Then now remember, if the value of a is less than 0, if the value of a is less than 0, I'll be throwing on quadrant 1, 2, and 4. So here are my quadrants. So I can plot my points. My point, this is quadrant 2. I want you to see this is quadrant 1. This is quadrant 2. This is quadrant 3. This is quadrant 4. Okay, so I'm going to draw on quadrant 2 and 4. Okay, yes. So now let me plot my points first. 4 and 0. 4 and 0, it is somewhere here. Okay, let me use a different color. Let me extend this line. Oh, that's a pain. Let me extend this line like that. So this is going to be 4 and 0. Somewhere here. Then we have 0 and 2. If this is 0, then 2 is somewhere here, okay? So it means I'm going to draw on quadrant 2 like that. If you are not sure about drawing your graph, please make sure you watch all my videos under these functions, okay? So that you do not become so lost. So this point here, it is how much? This point here, it is, okay, let me do this. 0 and 2. And this is your graph, or the graph of what? Graph of f. Okay. Cool. Write that. Okay. Now I do not want to remove the graph. I might need it. So let's see. Write down the values for, or write down the value of x, which f of x is less or equal to, or is less or equal to 0. This one translates to where it is below, or equal to x-axis. Okay, so less or equal. Less means below, then equal means equal. Okay, yes. So where is it below or less than? So it is below where on this portion? Can you see that? Can you see that on this portion? But here it is above. Okay. Similarly, here on this portion it is above, right? So you want this portion where it is below. Can you see it is between 2 and 4 because it does not touch 2, remember? It will just go down where the, okay, if we have our asymptote like that, blah, 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 your net will always go down. It will never cross or touch that point, okay? So we say it is between this point. So we say it is between what? We say it is between now, x is an element between what? 2 and 4. But now that 4, I have to include it. Why? Because the examiner said less or equal to. But the question is, why do I not include 2? Because the reason why I do not say like that, it is because now 2, it is an asymptote and there is no way I'm going to touch or the asymptote. My graph will never touch the asymptote, okay? I think I skipped this question. 0.7. I'll come back. Let me write it here. 0.7. I don't know how, but I'll come back to it. The straight line y is equal to negative 2x plus 5 passes through the point of intersection of the asymptotes and intersects f at p. It is equal to 1 and q. Write down the coordinate of q. Let me read that. So we are told the straight line y is equal to negative 2x plus 5, right? They say it passes through the point of intersection of the asymptotes. Okay. So point of intersection of our asymptotes, it is here. Here. Point of intersection between our asymptotes here. At a point, this point, it is x, which is equal to 2, y is equal to 1. So we have a point that passes, but that passes through that one. So we are told we have a line that passes through there. I don't know how, but maybe something like that. Okay. A line that passes like that. I don't know exactly where it passes, but I'm told it is a straight line. Okay. Okay, the equation tells me it is a straight line. So it passes through the point of intersection and intersects at 1 and 3, 1 and 3, and Q. Let me try to see that exactly what the examiner is trying to say. And intersects F or intersects F, our graph of F. So it means now, at 1 and 3, where is 1 and 3? We might say this is 1 and 3 somewhere there. So this is not a positive like that. So it is something like this, maybe. Okay. Such that it intersects our graph. Okay. Can you see? When I draw it like this, it now intersects my graph, and I'm told this point might be 1 and Q and 3 and Q. So basically, even if you do not draw that, what you have to know is that if this line passes through the point of intersection and does what? And intersects our graph of f, so we can say we can equate this to the graph of f. Okay, yes. So now I want you to see something. If it passes through this point here, which I said it is this x coordinate which is 2 and the y coordinate which is 1. This will act as a midpoint because this point here, which is point Q somewhere there, we are told point Q it is how much? 1 and 3. So somewhere somehow we'll have point Q. Okay, and you see it cuts here at this point which you call point P and cuts here at a point called Q, right? So we can say, okay, this will be the midpoint between where it cuts. Okay, so if that is the midpoint, we'll say, what is the, how many units did I move from 1 to 2? I moved how many units? 1 unit, right? So it means from 2 to this coordinate here, this coordinate of Q, x coordinate of Q, I should move 1 unit. So how much is that? So if I say 1, from 1 to 2, it is 1 unit. It means from 2 to that point, it is also 1 unit, meaning this one will be 3. Then I come here. From P to this point here, from 3 to 1, how many units did I move? I move -2 units, okay? I moved in the negative direction because it decreases, so I subtracted 2 here. So from here to here, sorry, from here to there, I minus 2. So it means from here to also that point Q, I should do what? -2. So 1 minus 2, it is how much? It is -1. So it means for coordinate of Q, it is negative, oh, sorry, not -3 and -1. What you can also do, you can say, equate f of x equal to y, meaning what is f of x? -2 x minus 2 plus 1, it is equal to -2x plus 5. Then solve for x. Okay. Solve for x here. When you solve for x, you'll get that the first x it is equal to, the first x that you get, x it is equal to 1 or x it is equal to 3. Then when you take this x and substitute it here, -2, when you take this x here and substitute it here or here, either way, it's fine. You'll see that you have -2 multiplied by 1, which is -2 plus 5, which is 3. So you'll have your y as 3. Or when you substitute this point here, x is equal to 3 here, you'll get -6, -2 multiplied by 3, which is -6 plus 5, which is -1. But can you see we're already given this point 1 and 3. So here is that point 1 and 3. When you're looking for 3 and -1, so it's fine. In the same. Remember question 3.7? Yes. Okay. Now we are told that it is further given that h of x it is 2 to the power of x plus 3 minus 4. Explain in ways how graph G must be transformed to obtain h. Now let's look at graph G. Graph G it is 1 to the power of half to the power of x. So half to the power of x, I can rewrite it like this. Okay, if I have half to the power of x minus 4. Remember, I can rewrite this as 2 to the power of negative x. Sorry, 2 to the power of -1 to the power of x minus 4, which is 2 to the power of -x minus 4. Now I want us to see what can be done to this graph to obtain what? This one. I want you to see something here. I want you to see something. Can you see that the x is no longer negative? It's now. So we want to move from this one to 2 to the power of x, sorry, x plus 3 minus 4. So how can we do that? Remember this one, there was nothing, okay? So it means whatever that was affected was the x. So how can I move from negative x? How can I move from negative x to positive x? Remember, to change the value of x, you have to translate or reflect across the y-axis. Remember, when you reflect across the y-axis, what happens if I have if I have x and y, what will change this x, but y will remain the same. Can you see if I reflect across the y-axis, my x will move from being positive to being negative. If it was negative, it will move from being negative to positive. So the first thing that I can see there here was, okay, the first thing that I can see was reflection about or across the y-axis, so that we can change this x. Okay, if we do that, if we reflect this graph about the y-axis, we will get 2 to the power of positive x minus 4. But now, can you see we are still short of plus 3? So remember, how do I add 3? Remember, on functions, on the x, when I have x plus 3, when I add 3, it moves to the 3 units to the left. If it is plus, if it is x minus 3, it was going to move 3 units to the right. You have to watch my video under functions to understand why I'm saying plus it is left, minus it is right. So here, the other thing I can see it is that number 2, what happened was that it was shifted. Okay, 3 units to the left. Done. Just like that. All right, now let's move on to the last part of the question paper, question 5. Okay, yes. Now it says now the graph of h of x it is equal to ax squared plus bx plus c, and this is the a parabola, and this is a straight line. Okay, and we're giving the straight line here, which the x-intercept of h are this one as well as this one, and the y-intercept of h is 0 and 6. Here we have m is a turning point, and d and e are the x and y intercept of p respectively. Good. Now, okay. Remember, how do I get the x coordinate here? Remember, this is the axis of symmetry, okay? So it is a point exactly between the x intercept. So this is the midpoint, okay? So how can I get this x? So from here to here, it should be equal from here to here, okay? So I can say the x coordinate of turning point. Remember the x coordinate of m. Let me say x coordinate of m here. X coordinate of m is the same as saying me is me saying negative 3 plus 1 divided by 2y, because it's the midpoint. So negative 3 plus 1 it is a 2, negative 2 divided by 2, which is negative 1. So here the x coordinate here it is negative 1. Can I see the distance between these two here? Is it equal to the distance between the two? Let's see. Negative 1 minus negative 3, it gives me 2. Good. 1 minus 1, it gives me 2. So the distance is equal. Good. But either way, yeah, we'll see. Okay. Write down the coordinate of D. What is D? D, it is the x-intercept of what? Of this graph. Of this graph. Let me just say, write this equation here, 8 minus 2x. So y is equal to 8 minus 2x. So if I want the x-intercept, sorry, write down the coordinate of D, which is the x-intercept, I should let y equal to 0. So I can say y is equal to 0, 8 minus 2x, then I take 2x to the other side equal to 8x, it is equal to 4. So the coordinate here, it is, when x it is equal to 4, I inserted y as 0. Like that. Okay, yes. Show that A, B, and C are those numbers respectively. Show that A, B, and C are those. Interesting. How can I do that? Cool. Remember now I want to find the equation, okay, of that one. Remember now I have what? I have the x-intercept as well as a point, okay? Remember the formula that I can use. Okay, I want this space. The formula that I can use is y is equal to a x minus x1, x minus x2, where let me say this is x1, this is x2, this is, okay, remember the coordinate here, it is 0 and 6. So this will be my y, this will be my x. Okay. Now let me try to substitute. What is my y? My y, it is 6. It is equal to a. What is x? X, it is 0 minus x1. X1, it is negative 3. X1 is negative 3. Then x, what is x? It is 0 minus what is x2? X2, it is 1. Then no, this is not 9, it is a. Then we have 6, it's equal to a into 0 plus this is 3. Then this is negative 1. So I know 3 multiplied by negative 1 is 6 equal to a multiplied by negative 3. So I divide by negative 3, I get 8 is equal to negative 2. Is it correct for the value of a here to be negative? Yes. Why? Because it is concave down. So remember, if the value of a is less than 0, meaning it is negative, it is concave down. It is said. If the value of a is greater than 0, meaning it is positive, it is concave up. But can you see here, it is concave down. So yes. So now that we have found the value of a, we can come back and say y it is equal to negative 2 into x minus, just substitute x1. X1 was negative 3, so it's the same as 3, x minus 1. Then just multiply negative 2 into, multiply this one, it will be x squared plus, we'll have negative x plus 3x, which is 2x. You know how to simplify this, right? Then y it is equal to negative 2x squared minus 4x plus 6. Now, can you see? This is my A, negative 2, my B it is negative 4, my C it is positive 6. Is that what they were looking for? Yes. A, negative 2, B, negative 4, C, negative 6, then I'm done. Okay. Then it means we are good. We now know the equation thereof. Okay, yes. Yes. Oh yeah, I can just erase that quickly and say now, okay, we are in position where we know the equation of our function. What is the equation of our function? Let me write it here. H of x, it is equal to negative 2x squared minus 4x plus 6. Good. Now they want us to find what? The coordinate of m, okay, the turning point. Now the coordinate of m, remember, you just want to find x, okay? Remember, how do I find x? I can say x coordinate of m, it is equal to negative 3. I'll show you the other step. Negative 3 plus 1 divided by 2, which is negative 1. And now substitute negative 1 into this function of h, such that when I substitute negative 1, I get the value of y. Well, say h of negative 1, it is, what is h of h? X of h, sorry. So it means when I see x, I'll substitute negative 1. Negative 2 into negative 1 squared minus 4 into negative 1 plus 6. So I have negative 2 plus 4, negative 2 plus 4, it is 6, 6 plus 6, it is, I think, it is 12. Please confirm there, okay? So it means now the coordinate of m, it is negative 1 and 12. Negative 1 and 12. The other step that you can use, instead of using this one, you can say x it is equal to negative b divided by 2a. What is b? It is negative 4. So you're going to say negative into negative 4 divided by, let me take this upwards a little bit. Okay, I'm back here. Okay, so divide by 2 into what is A? 8 is -2. So can you see I have this one will become +4 divided by -4, which is -1. Then you take that -1 and punch it here still. Will give you the same thing. So M it is equal to -1 and 12. Okay, yes, good, 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 cool, cool, cool. Okay, now another thing now I can do again. Oh, write down the range of H. Range, remember range, it is from the minimum. What is the minimum value? When I check here, the minimum value, it is -infinity, okay? It goes up to and it ends here, okay, on the turning point. So it means my range will be everything from y is an element from, it starts where? It starts from -infinity. Remember, it is from bottom to top. My top, it is 12. It is included. Or someone might say y should be less or greater or less or equal to 12. Now determine where h of x multiplied by p of x will be less than 0. So it means we want where, let me do this. Remember, so that when I multiply a multiplied by b, it gives me less than 0. It means a at least should be positive, this one should be negative, or this one should be negative, this one should be positive, okay? So it's either this one is negative, this one is positive, or this one is positive, this one is negative. Now let's look where h of x is negative, okay? Let's look where h of x is negative. H of x is negative here and here, okay? Then p of x is positive where? P of x is positive here. So you want where they intersect. Can you see? Remember this one will move up to, up to, up to, up to, up to. So can you see that from here, from this point here, let me do this. From this point here, h of x is negative, and what? And p of x is, h of x is negative, and p of x is positive, right? But this one goes up to infinity, but this one ends here. Remember, this graph can go blah, 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 blah. If we were to redraw it like this, can you see? It will stop here. So at D, this one stops being negative, this one up to infinity. So it means between, remember this one goes to infinity there. So between now, this point, between 1 and this point here, remember this point was how much? How much was D? Which is 4 and 0. So between 1 and 4, H is negative and P is positive. So we can say the first one that we can come across, it is X, it is between what? 1 and 4. Okay? Between 1 and 4. Another one that you can look at again, it is when H is positive, and X is negative. Where X is negative? Here. Can you find that? Can you see this one will be positive above, but this one will be negative? So there's no way they intersect. Can you see? If I draw my graph like this, can you see they do not intersect anyway? Can you see? Where they intersect, they are both positive because this one will come there up to there. So can you see? There's no way they intersect. So yeah, the only one that works, it is the one that we have already found. Okay. So yes. So X is an element of 1 to 4. Okay. So the turning point here, instead of 12, it is 8. I just confirmed my calculation, the y value. When we substitute now into this equation, it is -2 into -1 squared minus 4 into -1 plus 6. So this will be -2 plus 4 plus 6. So this will give us 8. So it means now we'll just change a few things. Let's say this is 8, and this is what is 8. Okay. We were still discussing this part, right? 5.5. Determine the values of x for which age of, okay. Now remember, I'll go back. Where is it negative? We said this one is negative. I just want to show you something. This is negative, and this one is positive from here. Goes there until. Okay, so we said from this point up to D, which is x is an element between what? 1 and 4, because remember the coordinate date is 4 and 0. This one is negative, okay? This one is positive. But can you see from here, this one is positive, this one is negative. So it means this one is also an intersection. It means from -3 to -infinity. So it means from -infinity to -3. We also have that part. Okay. So it means our solution, we have two of those. We can also say or, and when x is from negative what? -infinity to -3. If you prefer other interval, you can say, for this one, you can say x, it is between, so not equal, between what? 4 and 1, okay? Or if you prefer interval, you can say this x should be less than -3, just like that, okay? So yes, please take note of that. Rewind the video if needs be. Sorry for the mistake I did for saying now why it is 12 instead of 8, but yeah, just make sure you calculate your things correctly. So now 5.6 says, if h of x is k, determine the values of k for which the roots, okay, the roots here are non-real. Remember, if the roots are non-real, what happens? If the roots are non-real, it means now we do not have what? Let me come to my graph and remove this mess and try to explain this one. Try to explain this one. Mhm. Vamos a correr também. Tudo isso. 10 minutes. Um, okay, now we say now the roots are non-real. When what? When you do not have x-intercept. X-intercept. So we do not have the x-intercept. Can you see now in this case we have x-intercept, right? So what can I do to the graph such that, let me redraw the graph. I want to show you something. Okay. Now, what can I do to this point, to this graph, such that it becomes non-real? Okay, can you see if I go upwards, can you see, and stop here? Can you see now I still have roots? Okay, I still have roots. Even if I go upwards, how much? Remember this one, it will be continuous like that, right? But instead of going down like that, what if I go down and can you see I'm back to the original point? Now, instead of doing that, I can say, how about I go down? Okay, if I go down like that, okay, I took something, but it's fine. I go down like that. Can you see if I go down like this? Okay, let me try to up to this point. Can you see if I go from uh, 8, okay, let me use a pen, from 8 to 0 there. Can you see if I shift this graph, if I move this graph downwards like that, can you see now it still has a point there. Okay, so at this point it is where k it is equal to 8. Okay, where is that k? H of x, it is equal to k. Where is h of x? So plus k here. When k, I move it k, 8 units. When I move it 8 units, can you see it reaches this point? But can you see it still has a root? Okay, so it means if k was to be greater than 8, can you see here like this? Can you see if it is greater than 8? It is now, it does not have any root, it does not have any x-intercept, any intercept with the axis. So it means now the value of k should be greater than 8. Okay. So it means I should, from here to here, I said it is exactly 8. Then, but if I move a little bit, it means k should be greater than 8, meaning 9 units or 10 units, however, okay, as long as it is greater than 8. I believe you are following that. We are saying a should be greater than 8. Roots have the same sign. If they have the same sign, it's either, I want to show you something. It's either they are both positive or they are both negative, okay? So if I take my graph back from what it was, okay, okay, here's our graph. Now, if I want my roots to be, both of them to be of the same sign, it means I can take this point, okay? I can take this point here, and move it to the right, okay? So I can take this point and move it towards the right, okay? But how many units? Let's see that. If I take this point and move it, can you see from here, from -3, let me do this, from -3 to here, it is how many units? It is 3 units, okay? So I move it from here to there. I want you to see something. Okay? This is what happens here. Okay? If I move it at least 3 units to the right, this is what happens. It remains there exactly as it is, okay? But I want you to see something. If I move it from here to there, just a little bit there, they are both positive. But now we should know how. Instead of using this one, you can say, okay, let me bring back my graph like that. If this point here was to move, this point here was to move to the right, and this one was to move to that other side, what will happen? I want us to see something. So that it has two positive roots, I want you to see something. This moved, like it moved, like so. Okay? Like so. This is what we want. Both having what? Did they say positive? Or having the same sign, okay? It's either you're gonna move how many units? We should take note of that. It's gonna be from this point to that point, okay? From this point to that point, it is how many units? Actually, if you check between these points here, this is 8, right? And this is 6. If you move between these 2 points, if you move between these 2 points here, 8 and 6, 8 and 6, you get, if k is less than 6, so meaning it moves less than 6 units, then equal or greater than 8, like that. So this will be at least 8 units. From there, then this will be something like 8 units also. Okay. Or this one can move to that side. Okay. Okay. Now, can you see that if I take this point and move it to the other side, this one moved from here to whatever that point, okay? Whatever that point that we do not know, it is 8 units there. 8 units because we're translating this point from there, 8 units. And it gives us exactly, okay, if I translate it 8 units, okay, I want you to see something. If I translate it 8 units, it gives me, it brings me here, where this x here, it is equal to 0. But if I move it greater than 8, so if I move it greater than or equal to 8, it will have the same sign, okay? But if I take this one back and say I want them to become, both of them to become negative, it means which point should I shift? This point. I should shift this point 6 units to that side, okay? So remember here I included equal because this one, it is not exactly on the dot, okay? So I can move this point from here to there 6 units out. I can say, okay, from there, 6 units will give me that. So they both have what? The positive and negative x-intercept. So it can be greater than 8 or k should be less than 6. I do not include 6 because it was already, I found it on the dot, on the y-intercept. So when I take this into something, I say into number line maybe, if this is 6, 6 and 8, I'm saying this should be between, okay? Basically, it should be less or equal. Here it should be greater than 6 because I'm moving to the negative. Remember, when I move to the negative, I add. When I move to the right, I say minus. So can you see it is less than, meaning minus. So yeah, it is greater like this. It will go there and it will go there. So it is between 6 and 8, basically. So you'll say x, it is between 6 and 8. If you do not understand this, trust me, it's fine. Yeah. These questions, well, the last questions, they are tricky, but yeah, they do not affect, they won't harm you a lot, okay? Last question, 5.7, calculate how graph P must be translated so that so that it becomes a tangent to graph H. So now, how can we translate this this point? Oof. Okay, how can you translate this graph of P such that it becomes a tangent to this graph? Okay, we do not know. Again, we do not know. But now what we know is that It becomes a tangent when what? The discriminant of this one, the point of this one, and or rather the equation of this one and this one are equal, exactly equal. Okay? If they are exactly equal, now it should be translated. Now we'll say instead of 8 minus 2, okay, we want to h of x is equal to p of x. Okay? Why? Because we want such that calculate how graph P must be translated so that it becomes a tangent to H. So now we want to H of X, it is equal to P of X. But now H of X, it is equal to, okay, negative 2x squared minus 4x squared plus 6. So what is P of X? P of X, it is 8 minus 2x. But now let me add K so that I can see how much I translated it, okay? How much I translate. I want to know how I can translate how many units so that it becomes what? It becomes a what? A tangent. And if it is a tangent, the discriminant is exactly 0. So let's try to solve that. So it will become negative 12 squared minus, 4x. Then I take this to the other side plus 2x. Then plus 6 minus 8 minus k, it is equal to 0. Then I want to have my discriminant. Okay, let me simplify this a little bit. Negative 2x squared minus 2x minus 2 minus k. Okay, this is my a, this is my b, the whole part is my c. Okay, so I want my discriminant where my discriminant is equal to 0. This is where I'll get my tangent. So what is my discriminant? B squared minus 4ac. What is b? Let me write this. B squared minus 4ac, it is equal to 0. Okay, this is the same as saying discriminant. It should be equal to 0. So what is b squared? B squared, it is negative 2 squared minus 4. What is a? 8 is negative 2. C, what is c? C, it is everything. Negative 2 minus k. It will be equal to what? To 0. Let me try to simplify this. It will be 4 minus negative 4 multiplied by negative 2 multiplied by negative 2. It is negative 4 times 4, negative 16. Negative 4 multiplied by negative 2, it is 8 multiplied by negative k, negative 8k greater than 0. Then when I move on, I can say now what? 4 minus 16 is negative 12 minus 8k is equal to 0. Therefore, negative 12, it is equal to negative, when I take 8k to negative 8k to the other side, it becomes this. I divide by 8, I divide by 8. Then k will be equal to, when I divide by 8 by 8, k will be equal to negative 12 divided by 8, which is negative 3 divided by 2. So it means now k must be translated like this. Okay? Like something like that. Okay. Right. So yeah, exactly. So if it is negative k minus 3, so it means now when you write that, it means it should be, okay, it should be now shifted. Okay, shifted negative 3 divided by 2 is the same as negative 1.5. Okay, you can say shifted negative 1 or 1.5 down. Okay, yes. So this is your final answer. Shifted 1.5 units. Since well it is negative, you can say down. So yes, that's all. for question paper grade 11. So yes, we had a memo here. I don't know if you'll need it, but yeah, something like that. Just to confirm your answers, our answers there. Okay. 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 Then we had another one. Another one. You can pause and see and compare with the answers that we got. Another one. Another one there. Maybe if they have another method that they used, you can pause and see. Okay, 2.2.1, 2.1.2, 2.2.1, two methods, and 2.2.2, 2.2.3, two methods. Okay, then 3.1 up to 3.3, like that, you can pause. 3.4 up to 3.6, you can up to 3.5, yes, like that, you can pause. Then 3.6 to 3.7, those. Then 4.1 to 4.3, it is that. You can pause and look at the answers and confirm. 4.4 is that. Then our graph, it is up to 4.7, it is that. Okay. Then question 5, it is dot. 5.2. Then up to 5.3, my coordinates there. 5.4 to 5.5. Okay. Then the last question, 5.6, 5.6.2, then now 5.7. Can you see now, if the graph of P is to become a tangent, then implies mu y-intercept is unknown. So it is the original function and that one, okay? Then they simplify, they maneuver around. Here, they found K as 6.5, but can you see here they ignored there? So it means K, it is 8, like this. Here, K instead of K, they can say, okay, 8 plus something y value is equal to K. Now they got what? They got K as 6.5, right? So you can say 8 plus whatever the new y value is equal to, then y is equal to 6.5 minus 8, it is, sorry, negative 1.5. So can you see? Yes. Or you can use the same method that I used here, plus K, right? And find the discriminant. Where is it? The discriminant, then K will exactly be equal to what? Negative 1.5, then is a 1.5 units downwards. So yes, thank you very much. Yes, so yeah, we'll meet again. Okay, yes.